Hey Geometry, this is numbers 11, 12, and 13. Now you can do this right in the handed out packet, and this is kind of today's mini lesson on some multiple step proofs. Now we just did an overlapping triangle proof in number 8, and now things are going to get just a little bit more difficult in 11, 12, and 13, but luckily there's kind of a skeleton proof already laid out for us. So what I'm going to go ahead and do is I'm going to mark my givens. We have SE congruent to SU, angle E congruent to angle U, so it's an S and an A there, and we need to prove that triangle MES is congruent to triangle OUS. So not overlapping triangles here, there really isn't much going on in this part of the diagram. So we've got SE congruent to SU, angle E congruent to angle U, and it ends up being an ASA situation. So that means I got to do something here with angle 1 and angle 2. Well, this is a diagram step, and we know that vertical angles are congruent, and from our conjecture sheet we can write that if two angles are vertical, sorry about my ink there, then they are congruent. I'll go ahead and fix that. Two angles are vertical, then they are congruent. So therefore, angle 1 is congruent to angle 2. That goes into an ASA box, and out comes the fact that triangle MES is congruent to triangle OUS. And that proof is done. Alright, now let's go ahead and look at number 12. First thing given to us is that I is the midpoint of CM, and that I is also the midpoint of BL. And we need to figure out what triangles we are going to prove congruent. Now if I is the midpoint of CM, we know that means CI is going to be congruent to IM, and we'll go ahead and we'll show that in this proof later, and that BIL is going to be congruent to IB. So it looks as though we're probably going to be proving these two triangles congruent to each other. So I'm going to write that triangle CIL is congruent to triangle MIB. That's what we want to prove. And again, this comes from the fact that C to I is one tick mark, and so is M to I. And then I to L is two tick marks, and so is I to B. And we notice that angle CIL is going to be congruent to angle MIB, because these are vertical angles. So in the actual proof, we've got I being the midpoint of CM, which gives us that if a point is a midpoint of a segment, then it divides the segment into two congruent segments. That is part of our conjectures, so therefore CI congruent to IM. Now this exact same thing can be written right in this box, because this is a general case, and if I is the midpoint of BL, well, we know that IL will be congruent to IB as long as we include this in the box, that if a point is a midpoint, then it divides the segment into two congruent segments. So it looks like we've got our two sides. Now all we need is our angles, and this comes from a diagram box, and we've done this before, and we know that if two angles are vertical, then they are congruent. So if two angles are vertical, they are congruent. Therefore angle 1 is congruent to angle 2. Now we've got our side, we've got another side, and an angle, but in this case we actually have it in the order of SAS, so that's going to go in my box, and I just proved my statement that triangle CIL is congruent to triangle MIB. And I am done with number 12. So I'm ready to move on to number 13 now. Number 13, we are given that SA is parallel to NE, already marked, SE is parallel to NA, already marked, and that it says that we want to prove SA is congruent to NE, but in reality we actually don't want to prove that. That is an error in the packet. We want to prove that two triangles are congruent. We're going to prove that triangle SEN is congruent to triangle NAS. So if this is our triangle proof statement, we've got our parallel lines. We're going to have to use those in a diagram to eventually get to this point. Well, we know that parallel lines give us that alternate interior angles are congruent, and that's what this box says. If two parallel lines going in are cut by a transversal, then alternate interior angles are congruent. Therefore, angle 3 congruent to angle 4. We know the same with angle 1 and angle 2, and that is right here, because SE and NA are the parallel lines that give us those alternate interior angles. So we know that angle 1 is congruent to angle 2. So that gives us angle 1 congruent to angle 2. So we've got our angles. Now we just need a side in between them, or a side somewhere else. Well, it looks like SN is shared by both of these triangles, and we've already done that before, that if two triangles share a segment, that segment is congruent to itself. So if two triangles share a segment, that segment is congruent to itself. Therefore, SN is congruent to SN. Now we've got our angle, we've got our side, and our angle, side, angle. So I can put ASA in this box. All three of these things must be going in, our angle, side, and angle, and therefore triangle SEN is congruent to triangle NAS. Now that is 11, 12, and 13. I hope you pause that video at certain times to make sure you were doing everything correct. Your homework tonight is going to be due 14, 15, and 18, and I have keys to those as well as videos online for you to use. Thanks a lot.